Welcome to Teacher Mentor Tips. I'm the presenter, Lois Walton. I'm from Rocky Mountain Best, but I realize that this presentation may be seen also by some teachers or mentors from the Front Range Best Hub. So I'll try to keep my slides so that you can understand them from either hub. So this is a reminder. So if you're looking at the just the slides, you won't hear my voice. But if you're watching the video, this is a reminder that on the team workflow under your files shared with your team, you can also find the session presentations with just the slides and links to all of the kickoff, breakout, Q&A session meetings. So we just want to put this in so that you remember that you can get at these. You have found this presentation posted on the National Registry. It contains information to help you with your teams. This presentation is meant for teachers and mentors from two Colorado hubs, Front Range Best and Rocky Mountain Best. If you have questions from this presentation, please email the presenter, me, Lois Walton, at bestinc.org, and I'll reply as soon as I can. On the day of kickoff, Front Range Best will have this video that you're watching right now in an in-person Q&A session, so someone will be there to talk to it. If you can't attend that, feel free to join the link below. On the day of kickoff, Rocky Mountain Best will have an interactive session where you can give and receive suggestions from other teachers and mentors. Please feel free to ask questions or give suggestions in that session. It will work much better with your participation. Teachers and mentors from either hub are welcome to attend this interactive session using the link right here. Okay. So all of the kickoff sessions are recorded. And so there's lots of information in the other sessions if you want to go listen to them also. I've repeated some information here to highlight it for you, but I don't have the detail necessarily that are in some of those other sessions. So feel free to go listen to them to learn more about the engineering notebook or control system or whatever. Because this session is being posted prior to kickoff, there are no demo day specific items in this presentation. So if you have some discussion to do about that, we'll do that at on the 11th at the kickoff. I've included on this slide a couple of links that have helpful resources for you. One is to the Best Robotics website, and one is to the National Registry. The National Registry is the place where you'll go to get all sorts of things, the game rules, the sign up for team slots. You can get at the score sheets there. This is where you go to submit, your team goes to submit engineering notebooks and other deliverables. It's where they get software download instructions. And each hub, both Rocky Mountain Best and Front Range Best, will post and update their team handbook on this registry. This slide talks about the difference between this classic competition that we did in years 2019 and before, and the differences between that and what we're doing this year. So let's talk about it. So in 2019 and before, our competition was 6 weeks long, and it included all of these things. We didn't necessarily call them out, but it included a design of the robot and then constructing it, an engineering notebook documenting that whole process. The robot performance is the head-to-head that we have each year. And then for the best award, there was a marketing presentation, a team exhibit and interviews, and spirit and sportsmanship, in addition to the robot performance and the engineering notebook. So last year, because we were doing, a lot of the hubs were doing it as a virtual competition, we made this competition longer, and this year it will be 8 weeks long. So that's what's happening this year. It includes all of the parts from the classic competition that we used before, with the exception of the spirit and sportsmanship. That was difficult to have in a virtual environment, and because this year some hubs will also be only holding a virtual competition. We can't have the spirit and sportsmanship and compare across hubs. So this part of the best award, the 10 points, will just not be not allotted to anybody. And that means your total for the best award will be 90 points instead of 100. But the rest of it's the same as the classic competition. With the exception that last year we added a critical design review that is new with the activities from last year. It happens at about week 5, and we as engineers know that it's a great thing to do, because when you present to your customers what your design is, you can get a feel for whether it's what they want. In this case, for your teams, it will either be a mentoring session where the judges will help mentor your team and maybe give them some ideas of things they need to expand upon or improve or change, whatever. Or it could be a judged event, and that's what the mentoring is, what Front Range Best is doing. Rocky Mountain Best is going to hold it as a judged event, but if a team wants it just for mentoring, that's what we'll do. We'll mentor them. As a judged event, then they'll get points according to how well they do what's on the score sheet and the rubrics and that kind of thing. But and then could win an award. But as a mentoring thing, that it'll be a great, especially for the teams that are a little newer at this and don't quite understand what's going on. So we'll have it as both. And then in addition, last year we added several other skills, and these are also happening in 2021, with the exception of Best Mania. Last year we had a Best Mania IQ challenge that was held with Best Robotics, the national organization. This year we're not being able to have that, so that won't happen. But the rest of these are in the possibilities. Demo Days Minecraft was added last year as Outbreak Minecraft, which was the game last year. It's a Minecraft competition or skills thing that is held on a game that's like Demo Days, our new game for this year. So that competition is also held with BRI. They will award hub competition winners and championship winners. But so you can do it as part of either of our hubs, but we won't be judging it. That'll be a national competition. And then there are 4 more skills that were added last year that our 2 hubs are doing different things with. So Rocky Mountain Best is only doing the video design. That's the only one that we're offering to have judges and awards for. Front Range Best is choosing 3 of these, and I'm not sure right at this minute which 3. So for either of them, your teams will need to look on the registry or in your handbook to see what's being offered and when the sign-up dates are for, and when the due dates are for, if it's something that they have to upload. And then the last thing that I need to talk about is the Autonomous Challenge. And this year, that Autonomous Challenge will be held virtually, as it was last year. So this challenge will be held in MATLAB Simulink, and that you will be programming a virtual robot. It won't be the same as the robot that you designed for the classic competition or even the classroom competition. It'll be a virtual robot. And that requires that you use MATLAB and Simulink to do it. So I'll have more discussion about that later. So in this slide, we're going to talk just a little bit more about the activities that we're having this year. And I've learned a little bit more since the last slide, so I'll talk a little bit more about what Rocky Mountain Best is doing and what Front Range Best is doing. For this slide, the ones in the darker orange are required for all teams, and then the ones in the lighter are optional. So all of these tasks are required for all of the teams. They must do a robot design and construction. They're going to do a critical design review. They'll be held at different times for the two hubs, but everyone will do it. And it may be a mentoring session or a judged session, depending on what the team wants to do or what hub it was in. And they're then required to do an engineering notebook and the robot performance. If a team chooses to do the best award, then in addition to the engineering notebook and robot performance, they will also do a marketing presentation and a team exhibit and interview. So it's optional. It's optional if you're not doing the best award, but if you're doing the best award, then you do all of these. Then the rest of these in the lighter color are optional. I spoke about Demo Days Minecraft and how they'll do that with all of the teams across the nation. It'll be judged by the national organization. And the Rocky Mountain Best will be offering the video design. So check the registry or your team handbook for when you would need to sign up for that if your team chooses to do that. And these are the items that Front Range Best is doing. They've chosen to offer the video design, the engineering drawings, and the robot modeling. Neither of the hubs are offering website design this year. And then there's also the Autonomous Challenge, which I'll talk a little bit more about, but just wanted to note that it is done with the virtual robot and programming using MATLAB and Simulink. So this is just another slide that kind of gives you the same information as the last one, so I'm not going to spend any time on it. You can look at it and remember what I said on the last slide. But anyway, look at the registry for more information on these optional skills challenges. So this year your team has two opportunities for autonomous programming. The first one is the Autonomous Programming Challenge, which requires that they program a virtual robot using MATLAB Simulink. So no matter what software they're using to control their robot on the head-to-head field, this one would happen using MATLAB Simulink. And the competition will be held in the virtual playground. The second opportunity is during the classic or classroom head-to-head competition. There is a time when your students can perform an autonomous action in that head-to-head competition using whatever software they have used to program the robot. Both of these opportunities are optional, but we hope that your team will find a way to try them out. Let's talk about the National Registry and its use in 2021 and in the future probably. This is where the team handbook will be posted and updated by both hubs. The registry is also where parents and students satisfy requirements. The students need to fill out a survey prior to game day with demographics in it, and it's required. So if the student doesn't fill it out on the registry, then they will not be able to participate. This is where the team will find their team workflow. It's where they will be able to find due dates for different activities, and also where they will upload their deliverables like the engineering notebook. This is where they will find scheduled activities and where they will sign up for a time slot when that's necessary. This is where they get access to kickoff files and rules and software license keys and configuration files. It's also where they can get at the leaderboard. Now there are some things that if you looked at the registry right now, some things wouldn't be posted yet. You wouldn't be able to see until after kickoff. So if you look now, you might find some of the things online already, but they won't all be there until kickoff. Now let's talk about your role as a teacher or mentor versus the role of your students. Students do the work. Teachers and mentors teach skills and facilitate the processes. You should not design any of the parts or try to sell your ideas to the students. This needs to be their work and their fun. Let's talk about organizing the mentors on a team. If you can get other teachers or parents to help mentor, see who has which skills or interests to help the students. Is there someone who has done any kind of designing and wants to help them through the engineering design process? Is there someone who has interest in writing and is organized and can help them organize and write the engineering notebook? Is there anybody that has programming skills and would like to help them with that? Is there someone who's made presentations for their work or likes to speak in front of other people? Maybe they can help them with the skills that it takes to organize that presentation and present it. Anyway, see who likes to do what. Let's talk about organizing a team. There are plenty of ways to do it, and it probably depends on the size of your team. But let's just start. So you could divide the responsibilities by parts of the competition, like someone to lead the engineering notebook, someone to lead the preparation for the CDR, someone to lead the robot design and build, and a different person to work on the best awards, someone to lead with the skills challenges. That's one way. Another way might be to divide the responsibilities by the parts of the robot. Someone to lead the programming, someone to lead the work with the control system, someone with the grabber. Another way might be to divide the responsibilities by process. Have someone be a brainstorming lead, maybe someone be a safety lead and can make sure that everybody's following the safety rules. Someone to grab onto the rules and the Q&A and make sure that the team is keeping up with that. And you can kind of combine these differences however you can. If it's a small team, you may have to have people doing more than one thing. Once you've figured out how to divide that team up, you need to be able to figure out how to determine best how you can help them be successful in leading their part of the team. Also remember that if you come back the next year, some of the people who were helping in a team, just being a part of it, may roll into the leadership team as the other students graduate or move on. So hopefully after the first year, it'll be a little bit easier. Let's talk about communication. Figure out how your team will need to communicate among the team members. Will they do it in a normal classroom or after school? And just in case, what if some number of them have to be quarantined for some period of time, or you have to go remote for some reason? How will they brainstorm? How would they share documents if they're trying to create a document if they're not together? How would the students put together a deliverable in a remote environment? Determining these processes ahead of time may make the season go much better for them. Let's talk about safety. What are your processes going to be? How do you make sure that they are followed? Do you require a test prior to the use of a tool? Make sure this is documented in your engineering notebook. And there's places that can help you, and also maybe a discussion with other teachers. As a note, just just for general, for these slides. If you use the link to the coach's survival guide, the page numbers there are the page numbers in the charts and not the document itself. So if you go up to the top of the PDF document and try to go to page 50, you're going to end up on page 49. So you need to look at the page number at the bottom for what pages work for these little references that are in the charts. So help your team come up with a schedule, and then once they have, post it on a board or online somewhere where they can look at it, and have them try to mark on it whether they're keeping up with it or not. Did they actually brainstorm just in that first week, or did it end up having to last longer? When did they finish the design or the preliminary design? Did the CDR prep go on schedule or not? Anyway, so those are just some examples. This is an 8-week schedule, and it has, some items on it, but not everything. What would you add? What would you have them add to the schedule? And make sure that the team is involved in this process. And then consider putting it in an engineering notebook with some notes about whether they met those schedules or not. Okay, we're going to spend a little bit of time talking about the engineering design process. It comes in different formats. You can pick one and be sure your students understand it. We have an example in some of the following slides, but you certainly don't have to use this particular method. Just make sure that whichever one you decide to use with your students, that they understand how to use it. And don't forget to document whatever you choose in your engineering notebook. And also be sure that they remember that software is a part of this, and they need to do the design of their software and document that design in the engineering notebook. This is one example of an engineering process. So the first step in this one is to understand the problem. And then the next step is to explore the concepts and select one from the ones you've made. And then the next step is to analyze and prototype your robot. And then do your detailed design and manufacture the parts. And then integrate and test. And when you test anywhere along the line, they may make changes to the design and manufacture. Your drivers are testing the robot for your team and their strategy. When they do that, they may find many things that will drive changes to the software or hardware. Try to make sure that the schedule allows for these testing and changes. And a note about the slide and the note about CDR. CDR would normally come before detailed design and manufacture, so that you know that you're trying to build the right thing. Currently, Rocky Mountain Best is holding CDR at week 5, and Front Range Best is holding it with practice day, which would be week 6. So that may not line up with when your detailed design is set to begin. So you'll just have to, just work with that. But know that normally you would have a CDR before you moved on to that next step. Okay, the engineering design process, step 1 for the example that we're using is understand the problem. And that means that the students need to read the rules. That's where the problem comes from in this process. They need to determine from those rules what the requirements are for their robot and for their everything else. They need to research similar designs and then inventory the resources that they have available. What is in each of their kits? What can they use on this robot when they're trying to work with it? Engineering design process step 2 for this example is concept exploration and selection. So it has two parts to it. Um, exploring the concept and figuring out what you're going to do, and you'll get lots of ideas with that, and then you select one of them. So the first part of this step, engineering design process, step 2, is do the brainstorming. So your team can use brainstorming to come up with a strategy for their approach to the notebook, for the robot as a whole, or for components of the robot like the grabber or powertrain, or for attributes like constraints or goals or requirements. They can use it to come up with their best award components and how they're going to approach that. And your team could use it for safety planning if they don't already have a process defined. Some general things to remember when they're doing brainstorming. They need to remember to live within the design space and don't go wandering off. Review the brainstorming rules with your team before they begin. There's some tips in this Coach Survival Guide if you want to go to page 43 of that. Don't let them marry the first idea that they come up with. So make sure that they're being creative and letting the ideas flow at this stage. They don't want to limit them at this moment. And keep them from saying we can't or we have to, or you can't or you have to. We need to take off all the constraints. You can narrow down the answers later. These next two slides talk about a couple of different styles of brainstorming. Find the one that works for your team, and it may depend on the size and composition of your team for which one you use. The gallery method can be used in small or large groups to develop design alternatives. Each member sketches a design idea. All the sketches are posted, and then each member can comment on any of the ideas. Obviously, probably not the one that they came up with, but every other one. For the second method, it's called a 6-3-5 method, and basically this it can be done with any size team. This would be like a size with 6 team members. If you have more or fewer team members, then you use the n-3, n-1, and then n3. So each team member, if it's a 6-member team or 6 people are doing this part of the brainstorming, the 6 team members write down 3 ideas each, and they can do that in words or in pictures. And then the 5 members review each design idea. So they're not reviewing their own, but they're reviewing the rest of them. There's no discussions during the process, and that's just how this works. So those are 2 examples of ways that you could do brainstorming. There's obviously many more. So step 2 in this particular engineering design process is concept exploration and selection. And it has 2 parts, doing the brainstorming and strategy, and then selecting after you've done that brainstorming. So one example of a method that can be used to select a design is the decision matrix. And there's a pretty good description of it on page 44 of the Coach's Survival Guide. Probably better than I can do in this chart, but just some ideas. You try to narrow down all of your brainstorming ideas to about the best maybe 5 or 6 ideas. And you do that using a discussion, just an informal discussion among the team. Then you come up with some factors that will help you make that decision. Factors like, is it a simple design, which will probably end up being more robust? Is it a design that would allow predictable scoring? You would know that it would be easy to score at least one of the kinds of things you can score. Is it a design that's independent of driver skill, so that no matter who your driver is, you'll have some good competitions? Those are just examples. So you come up with those factors, and you create a matrix and fill in the values. Perhaps you put the factors that you're considering along the top, and you put the brainstorming ideas that you had along the side. And then you go through, and for each of the designs, you decide how good it is with respect to that factor, and put a value in that box. And then you sum them up for each of the brainstorming ideas. If they're along the side, then you're going to sum up across the row, and that should help you come up with a design that you're going to pursue, the one with the highest score. So again, if you can look on page 44 of the Coach's Survival Guide, you'll have a better description of this. So here's the example from the Coach's Survival Guide. I just thought I would talk a little bit more about it because it seems like having an example in front of you might be a little easier. So you'll notice that they've put the factors across the top, and the design alternatives that they've narrowed it down to 6 of them, put them down the side. You'll also notice that along the bottom that they've got different possible points for each of those factors. And I think that you want to remember that you would choose those possible points using the idea that maybe this factor and this factor are probably the most important. We think that's the most important for the team. This is the next most important, and then this, and then this, and then these two. So that gives different weights to what they choose for points for those values. And then they would have a discussion for factor A, whatever that was, and for design alternative 1. They thought this was a really good, it's worth 6 points, and they gave it 6 points. So it does that factor very well. Design alternative 2 doesn't quite do as good of a job, so they only gave it 3. And design alternative 3 doesn't do it at all, doesn't take care of that factor at all. And you fill in all of those parts of the matrix and then total them across and see what you get. And of course, which of these, each of these, none of them made 100, but it gives you an idea of which of the design alternatives does the best job. And when you're done with that, if you've got a couple of them that are kind of close together, or maybe 3 of them, including this one, you have a discussion about, are there parts of this alternative, this third alternative, is there a way to combine anything to give it, maybe you get even stronger idea if you did this. It's likely that one of these doesn't have anything higher. Well, like this one. Okay, so this one had a 24 here, but the one you're choosing only had a 12. Is there a way to make this design better using something from this design? So it gives them a way to kind of talk through some of those things. Okay, so now that you've picked the design that you're going to go after, at least for this moment, the next step is to analyze and prototype that design. So in this step, we're using drawings and prototypes to further the design of the robot. There's some examples on page 46 of the Coach's Survival Guide for this. But we're using the drawings and want to make sure that that your team records it in the engineering notebook. And you can use these drawings. They can use these drawings for their components, for the robot as a whole, or they can even use it for strategy. Maybe do a drawing that shows what their strategy is for competing in the head-to-heads. They can try cardboard prototypes, which are kind of a cheap way to kind of put it together and see how it's going to work. And they should try to make sure to put put some examples of what they've done in their notebook. They're also good things to show in their CDR presentation and in their exhibit, and perhaps even in their marketing presentation. So keep in mind that these things are usable in lots of parts of their process. Okay, this is the step where you do the detailed design and actual manufacturing. Remember that the better the design, the easier it will be for them to create the components. So have them spend the time on the design itself. In this step, the students create their components, and if they've done a prototype, they refine it. And they need to be sure that they build this from the kit parts that they've received and that they've planned to use. So step 5 of this example of the engineering design process is integration and test. This is where your team brings together the smaller components and assembles them. And the test part is where your drivers get some practice with the robot. Drivers need a lot of practice so that remember that when you're competing, you have to have more than one driver. So you have to be able to have each of the drivers have some practice so that they have a chance to get better. And remember also that it is their driving that can drive some changes to the software or the hardware when you watch them drive and see what's difficult or what's easy or what works well or what doesn't work so well, depending on the kinds of things they're trying to do for scoring. So it can drive changes that go back and make modifications in the software or in the hardware. And you'll have to figure out whether it's better to change it as a software change or as a hardware change. So it's a great process. And remember, don't wait until you think the robot is perfect to hand it over to the drivers, because it won't be. They'll figure out changes that need to be made. And they need time. So make it early in the process that you hand that over to them. So here we're going to have a little bit about the BEST Award. There is a whole session on this, so I'm not going to put all of it in here, and I will move through some of this fairly quickly. But it is our most prestigious award, and it's presented to the team that embodies the concept of boosting engineering, science, and technology. This year there won't be any spirit and sportsmanship, so the total points will add up to 90. If your team is going to participate in the BEST Award, then they need to sign up by the date given on your registry. Since we have 2 hubs here, and it may be different for them, so have them look in the registry or in their team handbook to figure out when they have to do it. And they'll have to sign up for slots for the marketing presentation and the team interview and exhibit. And just some hints, there's some pages in the Coach's Survival Guide which are good for getting some ideas. And then you need to remember that if you refer to the score sheets and the rubrics that go with them, you learn a lot about what the judges are expecting, and it can help your team kind of guide their presentations and so that it works the best for them. So it's really important for them to do that. And then they can use the same brainstorming to work on the components of the BEST Award as they did for the robot itself. And there's just a couple slides here. So this is also in the BEST Award presentation. But we're talking about, this is what they're trying to put together for the marketing presentation. This is what the judges will use. And there's more detail about this in slides in that presentation, and also there's a lot in the score sheets. So all of these things, this is the one for the team exhibit guidelines, and it looks at 3 different things, and the percentages are there. And then for the informal interview guidelines that go along with that exhibit. Okay, the next thing we're going to talk about is the Simulink Award. This is awarded to 1 team from each championship. So for all of our teams, it would be the Denver BEST Championship. But you submit it on the registry, and the software that you use for your robot must be MATLAB Simulink. So if you're going to enter this, then you're going to want to use MATLAB for your programming language. It's got in section 4.3.3 of the rules, it's got document for what what they get their scores for, how they get 100 points. And there's a way to submit. They have to do a video and a model. And so you have to be able to do both of those and then submit them on the registry. And the winning teams, you have to do that by 11 p.m. for all of the championships. It has to be by 11 p.m. local time on November 27th. And the winning teams will be awarded a cash award, a trophy, and a MathWorks hat for each team member. In the line of spirit and sportsmanship, it's very helpful if you folks would share your contact information so that if a teacher who is having some problems and wonders what to try next, those of you with experience might be able to help them out. And in order to do that this time, rather than have you email me your contact information and stuff like that, I set up a Google Sheet, and the link is on this page. And if you would fill out your information on that sheet, then you can go back later and see if there's someone there that you could contact for help. And assuming that you've put your name there, someone else might contact you. I put several fields on it, and I filled out the top row with my own information. I don't have a school, so I left that blank. I don't have students either, but I put age ranges in there to kind of give you an idea of what you might fill in for your information. So, and feel free to call me using the information in that sheet. And please leave a message because my phone filters if I don't have you on my contact list. So this is a look at what I put on the sheet for you. I've got your names, your first name, your last name, your years in best, your school name, and a place for you to put your hub name, Rocky Mountain or Front Range. What age of students you have, so whether it's middle school or high school or all the way through, your email, a phone number, and then the things that you can share. Can you share equipment or tools? Will you have a game field that some could share with another team? Can you share some tips? And I've made, if you have the link, you can edit this form. So if you decide you want to add another column, you can do that too. This is going to be for you folks. So just kind of as a wrap-up, try to use each of your students' skills and creative abilities and be sure that you have fun and that they have fun. And I wish you all the best for this competition here. One more word. Don't forget that at least Rocky Mountain Best will have a kickoff exit survey. Not sure about Front Range Best at this moment, but we will provide the link to that survey in an email on September 11th. And if Front Range Best is going to have one, they'll also do the same thing. Before you fill it out, please ask for feedback from those students and mentors that attended different breakout sessions. Try to get some feedback from each one. And then we remember that we try to use this feedback every year to improve. So we really want you to do it. Please submit it online. And thank you so much for your participation in this. One more word. We always have one more. Have your team read the rules and technical data and the score sheets and the Q&A on the registry again and again and again. That's really important. And then this is a reminder from that's in all of the sessions.